Okay, today we're doing transformations. This may look familiar to you because we've done transformations several times this year. Right, okay, I need phones away, headphones out. All right, or I can take them out. Okay, all the way out, not just hanging on your ears. I know you can still hear them. All right, out. Okay, if I had students making good grades with their earbuds in their ears, I would think about it, okay, but it's not usually correlated with making good grades. Not listening to the teacher is not usually going along with making good grades. Okay, if it was, I would think about it more. Okay, all right, transformation. Again, it looks probably familiar to you. We've done it several times. The only thing that changes is the type of equation, the type of graph we're transforming. Okay, it's still going to be real similar to what we've done in the past, where like plus moves it up, minus moves it down, negative out front is a reflection over the x-axis. Y'all remember all that? Right? We've done it a lot, right? Okay. The only difference is we're doing two different types of graphs today. Exponential is this one, and we'll do logs, which we talked about last class. And this one's a little bit weird because the exponent is the variable. Okay, so this one, what you're going to do to it is going to be in the exponent, right? Horizontal, left and right transformations, you can see, usually those are what's inside parentheses. Okay, this one, instead of that, it's what's up in the exponent. Okay, left is plus in the exponent, right is minus in the exponent. Up and down are still just added on to the end. Okay, plus 5 will be up, minus 1 will be down. Right, then if it's negative out front, that's over the x-axis, flipping down. Okay, if it's a negative in front of the x, up in the exponent, that's going to flip over the y-axis. Horizontal shrink and stretch is still the weird one. Okay, it's a little bit weird. You have to take the number that you get, like this one is to the 2x, and it shrinks it by 1/2. Okay, that number, we're going to take the 2, flip the fraction. Okay, remember that one. That's just a funky one. It has a weird rule. For horizontal shrink and stretch, you flip the fraction, you find a reciprocal. So if it's 2, it'll be a shrink by 1/2. If it is divided by 2, you flip it, it'll be a stretch by 2. Okay, where vertical stretch and shrink stays the same number, you just put the number right out in the front of the equation. Okay, a whole number would be a stretch, and a fraction is a shrink. Okay, all that's pretty much review. This chart we've seen on almost every time we've done transformations. You know, it's just a little bit different for each thing. Here it tells you in words what's going on. Here it tells you the f of x notation. I really like to use the examples because you can tell exactly what you're supposed to be doing, how it will look in the equation. Okay, so this is the column that I use the most. Refer back to these. Okay, yes, we can check all of these by looking at the graphs in the calculator, but you've seen our calculators. They have little pixels. They're not the easiest graphs to read sometimes. Okay, that's why we're learning. We can see what's going to happen to the graphs by looking at the equation too. Okay, we don't just need the graph in the calculator. Okay, because sometimes it's not going to work. Maybe it's too big or you can't tell the difference really what's going on. It's easier if we just understand what's going on here. We're going to have 8 problems. Okay, we're going to graph some of them in our notes. The first one, the instructions are going to be describe and graph the transformation. That looks like one word, but it's 2. Describe and graph the transformations. And all on these, describe and graph the transformations. You might remember this, we've been doing this since the end of last 6 weeks in last class. A lot of these numbers are, because of the exponents, there's going to be so many decimals. So we're just going to sketch the graphs. We don't have to make them perfect, okay? Because like we saw before, a lot of them we had to round anyway. So we're just going to make the graph look as good as we can. Okay, let's see. Number 1, in the computer, f of x, the one you start with, is red, and g of x is going to be blue. So I'm going to do that as much as I can here, so you can see So it'll look the same as what's on the practice, okay? So first, my f of x on this one is just going to be 1/2 x. And my g of x, right, it's been transformed, is going to be 1/2 to the x power minus 4. All right, and on these, you might see the number and think like that's a vertical stretch, but on these, that's the base. Remember, the base has to be at the bottom. A vertical stretch or shrink would be outside the parentheses, okay? So, and since this stays the same, it's 1/2 in both of them, is not one of the transformations because it's not a change from this to this since they're the same. All right, so first of all, let's just looking at the f of x. It's exponential. Is it a growth or is it a decay? All right, decay. How do you know it's decay? You're right.